Hey, hey!
I wanted to talk a little bit about. I don't have slides or anything. I was going to try to live code some stuff here, but I wanted to talk a little bit about RxJS. Not so much like what it is or that sort of thing. There's lots of talks on that, and the thing that I really wanted to talk about was more like what's been going on recently with RxJS, where I've been reducing the size of it without changing what it actually does and actually increasing the performance quite a bit. So I'm going to attempt to kind of live code some of those changes and show you the thought processes that go on. But the first thing I want to talk about is whenever you're refactoring code, it's really, really important to make sure that you have a ton of tests, and not just any tests. You want to have integration tests. And integration tests for a library like RxJS, because it's a utility library, look a lot like unit tests, but it's an important distinction that we're testing the public-facing API to make sure that certain behaviors stay the same. So we've got almost 3,000 tests against the library, and they're exhaustive. And some of the tests probably even repeat themselves, and I don't care. I'll just leave them in there because what that does is it provides the safety for me to go through and like really truly refactor the code underneath and make sure with each step that things are still passing. I'm not going to run the tests right now. They actually run pretty quickly because we have them all virtualized, but time-wise. But I'm just going to be using like Stack Blitz to kind of show this stuff. So let me share my screen. Let's see, share screen. I'll get like the Inception thing where it's like copies of me. Oh no, it didn't do that. Oh, there we go. So I've got like, whoa. All right. So let me increase the font size. Oop, that's decreasing. Increase the font size here a little bit. What I've got here is I'm just pulling in this simple apparatus here. So of comes from RxJS, and just for the unindoctrinated, what of is, if I were to comment this out, is you can say of, 1, 2, 3, and what it does is it pushes values out of whatever you put in here. So if I was to be a little bit more verbose to make this more obvious, I could put this like so. And basically it pushes these values out, and you can put, whatever you want in there, and it'll push them all up. And then it completes. So this is like a very, very simple way to create an observable. But what I want to do is talk about these operators here. So a really, really large chunk of RxJS is actually operators, and I can actually look that up really quick. So I've got these tests that kind of test like it does bundling here. So this is like an Angular CLI app, and inside of Angular CLI we've got there's a little bit of wrapping here. The one I most look at usually is this bit here, the internal. So this is all the guts of RxJS. Like literally, I've included the kitchen sink, things you wouldn't even use in here. And you can kind of see like how expensive some of these things are. Like you can look and be like, oh, if you use buffer time, it's going to cost you 2.2 kilobytes and so on. So this is version 6. So 663 is the latest version that's currently released. And you can see that the operators especially are 51 kilobytes of that 93. So there's a lot of room to shrink these other things down, but this in particular is pretty intense. And you can look and you can say like, okay, well, let's find map. So map is right here. It's 525 bytes. And this is kind of the starting place where I started refactoring this stuff. And it would be great. The goal I had was to try to get this under like 30K. And so in order to do that, I had to look at what we were doing internally. And I've kind of copied and pasted what the map operator looked like into this file here. I'm going to give us a little bit more room to play with. So all of these operators were written about 6 years ago against V8. I believe it was like Crankshaft or something. Like it was a couple versions of V8 ago. And a lot of this code was highly optimized to perform well in that environment where closures were not very fast at all. But now closures are on par with, you know, other means of getting state inside of a function. And like when closures weren't fast, what we were doing is we were actually adding properties to classes. So we didn't have to close over the properties. We could get them in through this dot whatever. And so what this means is that this stuff was really fast in the older V8 runtime. But as you can see, there's a lot of boilerplate that goes into a mapping function in here. And I really want to reduce the size of this. So the way that you go about doing this sort of thing is you can go in and you can kind of just push things around and do stuff. And like one of the things I did do is in this pass, at least because we're very inconsistent about these sort of type checks, is I might go in and like remove this type check, right? Because we're not doing these same type checks elsewhere. And we might go back and do the other thing is we're mostly used by TypeScript users. So this is actually punishing them for using TypeScript because we're doing safety checks for people that don't use TypeScript. We've got other things that we've got in the books where maybe we're going to go through and publish like some sort of monkey patching bit that goes through and adds this for people that require the extra type safety, or maybe we go through and we add like a very small type checking thing for some of this. But like, so one thing like easy money is I can go through and I can remove this, but arguably that's not the biggest win. There's a lot of other stuff that's going on in here. And if you look at like filter, it's the same sort of pattern where you've got this filter operator and then you got this filter subscriber and so on and so forth. So the very first thing I did was look at this and think, okay, well, I've got this, and we conveniently called this method call, which is a horrible name in JavaScript because everyone knows that if you have like, you know, a function of any sort, you can say function.call, right? So there's a call method on a function, but that's actually kind of nice that we did this because that means that I can stop having this class that sends things in through a constructor and closes over them and everything. And I can just close over it with an actual function. So I could go up here, and as long as my this context is the subscriber, this should work. So I should be able to go in here and just say, all right, function, this is a subscriber, and we'll say it's a subscriber of R because that's where we're going to send things to. And it takes a source. The source is any here. That's actually incorrect. So it's an observable of T is the source. And this is the lifted source. And I'm going to talk about what lift is here in a second. But the important thing is I'm refactoring this bit. And then I've got inside of here, I'm subscribing to the source with a map subscriber. So if I do that, this, and I don't need these anymore. If I do that, then save it. Let me format that because it's bad. Then save it. And I run this again. I get exactly the same outcome as I did before with my map. So my map is doing exactly the same thing right now. We'll just kind of use this as a pseudo test. Normally I would run my entire battery of tests to make sure that everything works exactly the same after this change. And I no longer need this bit at all. So I've already reduced the size of this pretty substantially, right? And I can go in and I can do the same thing with filter. So I can go in and be like, okay, well, here I've got this call, return this, yada, yada. So this is going to look exactly the same where I take this and say, function, this is a subscriber key and a source of observable key. And right here we do shenanigans. Pretty much same thing. And get rid of this because no one's using it. And run it, and everything's exactly the same still. So we're doing okay. So we're able to reduce this sort of stuff. Just to talk about what lift is really quick. So lift, and I'm actually going to show you this. Maybe I'll show you it in 6x, but I'll try to show it to you in master. It is this mechanism that's a little convoluted, but it helps performance a lot. So if I go to 6x and I look at the observable implementation, I wanted observable. So if I thumb through here and I look, I've got lift. And what you can see lift does is it's responsible for creating a new observable that's created in a kind of a weird way where it's not passing an argument there. And then it sets this internal property source and this internal property operator to whatever you passed in there. So source becomes this. So basically you're saying, okay, my actual source is the current observable that I've got. And the operator I want to use is this. And then we return it. And then what happens is when you subscribe to this returned observable, go to subscribe. When you subscribe to that return observable, it comes in here and it says, hey, it gets its subscriber, or whatever, which is just kind of scrubbing these things to add some safety. And then it says, hey, do I have an operator that I just pulled off of this? If I do, I want to call it with the actual subscriber and with the source, which you'll remember was our previous observable that you operated on. And that's it. And this add is just like, oh, I'm adding the subscription that this returns to my returned subscription. Now, the thing about this is that means if you chain multiple operators along, what that means is there's one observable that everything is subscribing to, and this call is responsible for setting up the subscription to the source. So it is saying, okay, so this one is a lifted observable. So in the case of my thing here, so when it subscribes to map, it's actually subscribing to the one that came from filter, which in turn subscribes to the one that was at the head here, which is our original source. So it kind of flattens all of that by quote unquote lifting the operations onto the original source. So that's kind of how lift works, just to kind of explain that. But it's not super relevant to like how I made things smaller. It's just relevant to like what this weird mechanism is that I'm setting up here. I just wanted to explain it. Now, the other thing is, so I can go through and I can get some savings through our operators. And there's, as you can see, there's a lot of operators in here. And every single one of these has that same sort of lift and operator mechanism. So I can go through and I can reduce things quite a bit. Some of these operators are already based off of existing operators. So that kind of like pluck is based off of map and so on. So that's why they're already pretty small. But I need to get more savings out of this. And if you look through all of the code, every single one of these custom implemented operators has this class that extends like some subscriber, filter subscriber, or in this case, map subscriber that extends subscriber. And its whole responsibility is to take in, this destination, which is where we're forwarding our messages along to, and wire that up. And I'll talk about what that means in just a second. And then also take in these properties and kind of set them up so we don't have to close over them in something. And then this is overriding. This is overriding, actually. What is this? I don't even know what that comment is. Let's remove that. It's horrible. Anyways, this is overriding what's happening in subscriber. So I'll show you what's happening in subscriber really quick. That's the wrong subscriber file. We don't have all this compat stuff in the other one. Let's see, subscriber. Increase the size of this a little bit for you. So subscriber is this type that extends both subscription and observer. Now, an observer is an object with a next, error, and complete method on it. And there's all this convoluted logic in here that's also been reduced in the newer version. But like what this is doing is it's saying, okay, well, if you give me a destination, and in fact, I'm just going to switch to master because it's so much easier to look at. You give me a destination and I set this destination. And then when someone calls next on me, if I'm not stopped, then I call this underscore next, right? And the same thing here. For error, I call underscore error, but I also mark it as stopped, and that just kind of prevents it from being reentrant. But the important bit here for my filter and map especially is if you look at our implementation, we're overriding that next, and then we're forwarding along to the destination, which again, if we look at the code, is precisely what this was doing. Like if I go into underscore next, right there. So I've got this pattern in both of these. And this pattern, in fact, exists in a lot of different places. So I think that it would be great if instead of having to pass these things through a constructor, if I could just have a function that kind of closed over this. And so I had this idea, well, maybe since these two things are so similar, I can just create a new thing, and I'll call it, actually, let's do it in here. I'll call it the operator subscriber. And operator subscriber is a class extends subscriber. And in our constructor, we can do something like this. We can say, okay, well, we've got our destination. The subscriber, any, we don't really care where it's going. And we'll make sure that goes along. And then the other thing we can do is we can just provide this optional like on next. We don't do this in every single operator. We don't always handle next, but frequently we usually handle next. But I'll just go in here and say, okay, if I get a value t and void, and I can say, if we have on next, and we override next directly as a property and just set it. If I do that, I can go into, let's start with map. I actually don't need this anymore. I can come in here and say, okay, well, how about this? Do operator subscriber. And I'm just going to make this destination easier to read. Pull that in. Destination. And whenever we get, and this is our next override, whenever we get a value, we do what's in here. I don't need this anymore. I don't need this anymore. This is supposed to be passing in an index. I don't even like that name. We'll call it index. And we need to create index. So we pass an index to our projection function. Let's format that a little better. We don't need that anymore or this anymore because we've closed over it. Here we are. We no longer have this map subscriber. We can get rid of that. And we've made map work. Let's see if we can do the same thing with filter. So filter, it's the same basic principle. I can go in here and say new operator subscriber. I like to name this so it's a little bit clearer. these value and value is gonna, that next method is gonna do exactly the same thing as this. Like that name count. And we've successfully removed our filter subscriber. So now this is already a lot smaller than our original implementations, right? And you know, I went through and I got the whole library to do this, and then I realized that there's this thing everywhere. Now, this is a situation where anytime someone provides us a user-provided function, so our predicate in this case in filter, or our projection function here in map, when you provide a user-provided function in Rx, we wrap it in a try-catch, and if anything bad happens on it, we send it to the destination via the error channel. So it's kind of a more functional way to handle this, instead of being like, oh, I'm just going to throw it, because this is handling asynchronous things. If you throw it, it's going to be in some uncatchable stack. So we push it out through the error notification. But you see, we're doing the same exact thing in both places. There's a little trick here where you can see that we don't try over top of the destination next, and that's just so if any errors happen in this, we're not catching that and then sending it. But the same pattern exists everywhere, or in a lot of places. So I thought, well, maybe I could try to do that catching at like a higher level. Maybe I could come up in here and say, okay, well, this is going to be, I'll get a value and say, you know, if let's do a try catch around this call. And then I can just forward that to the destination here. A little bit. So now if I have this and it still works, it's not doing anything different, I can go into these and I don't need this try catch anymore, because this is actually being wrapped in something that's going to do that for me. So that means I can just take this and be like, okay, well, this is there and this is here. And it looks like I don't even need to stuff that in a variable anymore. I can just put it right in line. Smaller, and then I can go in here and I can do the same thing. I don't need to do this anymore. I can just go here, and I can even inline that if I so choose. So, and now we're looking at much smaller version. So it's this as opposed to, you know, coming into here. We can look at 6x branch and then internal operators filter, for example. So this is, I mean, comments aside, you're looking at, oh, I don't even know, what is that? 50 lines of code or something like that for this, as opposed to what we've done over here, which is, you know, if you're really annoying about it, you can make it one line, but these are, it's just much cleaner. Now, the other thing that I noticed as I was going through and looking at this, like after all this work is done, is that we're doing this all the time. So this here, I can clean this up. This doesn't need to be named. Say that this is returning there. And like, we're doing this all the time. We're creating a function that returns this source.lift. And what we can do is we can actually make one more helper, and we'll just call it like operate. Operate, what it can do is we can say export operate, and it can return our source key. I have to add some types to this. it does our source lift. We can even clean up some of the weirdness around having to have this subscriber R. This is our lifted source. T. Equals this. So I can actually change this around to where I can say, all right, well, I'm going to have this take a callback that takes the lifted source and the destination, and returns what's called teardown logic. Now, what teardown logic really boils down to is you can return either void subscription or function void subscription or void. Right, so it's kind of what we're doing there, but I'm just going to call that teardown logic. It's just an internal type. It's actually exposed. You can use it directly. So any of one of those things that you could normally return from inside of an observable declaration. And now I can just say return callback with lifted source and destination, which ultimately I can inline to this. Now I have this operate function, and I can go back, and all of this extra boilerplate that's happening here, I can remove some of that. So I can go in and say, like, I still need to have this subscription occur, but like this bit here just becomes, let's see, operate source destination. And pull this in. Let's clean things up a little bit. It still works. So now that's gone, and I can go in and do exactly the same thing here. And it's pretty much a copy paste motion, but I can go here, filter, basically kind of take all this, make sure this is imported. Same thing. So now we've got something that's much, much smaller. This can be used throughout every single operator. This can be used throughout every single operator. And we've added more features. This is just kind of the basic one. Like you'd add things for on next, on air, on complete. There's some extra handling for unsubscription in a couple cases. But overall, this is how I went about making it smaller. And the important thing was between each one of these steps, I had a huge battery of tests that I was able to run and make sure everything was exactly right. But the other thing too is, is this more or less readable than the other one? Debatable. But as part of going through and doing all this, I've tried to go through and add extremely detailed comments. So if I was to go back in here and let's switch to master's version of filter. Yeah, you can go down here and you can see it's pretty much the same thing we just implemented, but I've tried to add detailed comments, just assuming the next person that comes along doesn't have the same context that I do. Still need to probably go back and fix docs and things like that. But the important bit is that these things are all covered here. And I've also kind of self-minified some stuff here like this. Not super important to do that, but in my opinion, we don't have anything to constantly check size during CI. And that's something I want to add before I go through and remove these things, because I'd rather not rely on tooling to know that we're getting these benefits. I'd just rather make sure that it works. And usually like Cursor or Closure or something like that is going to go through and make those things even smaller than whatever I did here, probably. So it's a little bit of me just, being superstitious, but yeah. And then there's some things that I was able to change to like ternaries and other stuff that I don't think Cursor would have done, to my knowledge. So But the important bit is, as you make the changes, you have a lot of tests with which to check. And then the other thing that's important about this is when you're going through and you're refactoring, like looking for repeated patterns. Like, what am I doing over and over again? What are things that I should know about how this works, and so on and so forth. There's some interesting stuff about this. So in here, for example, whenever you add a subscriber to an operator subscriber, I could actually even make that one smaller. If I go up in here and I look, and I've got, let's see, subscriber. So if I look in subscriber, it says, hey, is my destination also a subscription, which any subscriber would be? Then it automatically chains the subscriptions for me. So it's saying add myself like to this destination as like a child subscription. So that's already done. Where like when I'm returning this code in here, this return, it's saying take this subscription, return it, and it propagates out of here and adds it to the same subscription that this is. So this is actually not relevant. Like you don't need this in either one of our operators to make sure that the subscriptions are chained. So I can go through and actually remove that in both spots. And then we discovered that, well, you basically never want to return that in there. And we went in and said, okay, well, maybe instead of returning a teardown logic here, we say, no, you want to return either void or that. So you can just go in and so now if I still had that thing in there, it should complain. Now, is it not complaining? Why is it not complaining? It should complain. Perhaps this is not as friendly with the TypeScript stuff as I would have hoped. But yeah, so this should be invalid. I don't know why. Oh, maybe I didn't save it. Subscriber filter map. Oh, I don't know. It's looking like StackBlitz is having some weird issue. But either way, we're able to kind of force things inside the library, like to prevent us from doing the wrong thing, like trying to add the same subscription to a parent twice and that sort of thing. But yeah, you can go through and just kind of look for repeated patterns, and then you have to try to really think about what is each individual piece doing? What does it do for you? Step through the code. Even if it's code you think you're already familiar with, step through it and be like, oh, wait, I'm adding this thing twice. Like, why am I doing that? And that's kind of, how I discover some of these things. And then, the rest of it is, it's a little bit of code golf to try to reduce the size of this, but the important thing is refactoring. And this could be for any goal. So you could say that you've got, kind of a buggy implementation of something, or a convoluted implementation of something at work. And everyone has this in work like projects, because you are dealing with old code bases and people under time constraints and that sort of thing. The important bit is you don't need to big bang rewrite everything from scratch. I had no idea I would end up at this pattern when I started. I literally went through and was like, okay, what's one thing I can do? And then moved it a little bit, made sure all my tests passed. And then I thought, okay, well, what's something else I can do? And then I moved it a little bit and made sure all my tests passed. So it was iterative, and it could have been done over a long amount of time. And in fact, there was a lot of work that was done prior to what I just showed you here that kind of enabled things to get a little bit better, and things enabled me to see some of these patterns. Because, for example, like knowing that I didn't need to return this here, I kind of knew it at some level. But if you look at what's going on, so this is subscriber and master, super clean and easy to understand with some comments. If I go to subscriber in the 6x branch, and you look at this is the constructor, and it's got all this weird stuff in it. And I know what it does, but like sync error throwable and all this, there was a lot of refactoring that had to be done in here to simplify it. And once it was simplified, it became very obvious like what was happening inside of there. And it was the same sort of process. I went through and just slowly kind of pushed things around. So a lot of people, when they encounter like, oh, this app at my work that's just garbage and it's so bad and it's the code here is so convoluted, the only thing we could possibly do is throw it out and rewrite it. And I have done that with RxJS. There's branches in here where I was like, oh, I've got these experimental branches and I did these things. I want to try stuff out. And I introduced new bugs in some of the branches, and they didn't even end up as being as small as what we have here. So if I can actually show you kind of where we're sitting at now. So this is what we had before. And after going through and refactoring this stuff, once everything I've got now lands, this is where we're at now. So I remember I was saying that before I was trying to get operators under 30K. Now I've got it under 20K, like handily, easily under 20K, and it performs better. So, and this is all the byproduct of that process of just taking the code base that I really honestly did not like, I'm not going to lie, and being like, okay, so what can I change to make this smaller without breaking anything? Okay, now what can I change to make this smaller without breaking anything? And it's the same sort of thing. So just have a goal in mind and make the smallest changes possible to get there, and make sure that you have integration tests covering everything to make sure that you don't break anything, because then you have confidence that your change is good. So that's the crux of my talk. You can see now that map, before it was, what we looked at here? It was 525 bytes. Now it's 95. So substantially smaller. And this is roughly, kind of what I showed you in our example here. So I guess I'll pop back to StreamYard and see if there's any questions.
There were a lot of questions during the talk. So first of all, I just want to say that this is great. Like, one of the biggest issues in JS, in my opinion, is like the amount of cargo culting that has to happen when you do performance code. I remember like a talk with you, like I think it was 2-3 years ago, where there was a hack where you put the property on the object with like on the function, where the function is an object, some sort of like engine voodoo. I'm very happy to see like the percent of engine voodoo decreasing and the code becoming more readable, and I think it's like way nicer than the new style.
Yeah, I'm happy to. Having that stuff out there is like, it's like, originally, it did what it set out to do. The goal was to make it as fast as possible in the runtime, and it worked. But like, as time goes on and the code gets long in the tooth, like, it's embarrassing to go back and look. And then you have to explain things and be like, why? They're like, why is this here? Like, you get the kind of snide comments and the repository issues, and you're like, okay, yeah, thanks.
I've never seen a snide comment in a repository in my life.
You're right.
All right. So I think we have time for 2 questions. One from Ben Stav, who actually gave the first talk, and one from Nimrod. So Nimrod, I'll start with him because he has a very concrete question. He asked if you can show an example of an integration test.
Oh, okay. So in Rx, we have all sorts of marble tests. So let me go to the repository. So in integration tests, now I'm going to just clarify this, that the integration tests that you would have in an application are drastically different than the integration tests you would see in this utility library, because we're testing functions. Our user interface is just a bunch of functions, so it's going to look like a unit test. But the important bit is, I wasn't testing like the subscriber or just the operator or whatever. We were testing map as it would be used in the wild. So let's go and we'll find map in here. So map, and in map we have these marble tests. So we're saying, okay, so if I get a cold observable of 1, 2, and 3, and then I apply this mapping function to it, I expect the results to come out at these times, and I expect the results to equal these things. And so I've got just tons of these. I've got like one for mapping multiple values, one for mapping one value, and it's just exhaustive. Like, you'd think, oh, it's obvious it would do both of these. Like, I'm of the school of thought, I don't care if it's obvious. Let's just cover it.
Ben,
Yeah.
Can you share the screen real quick?
Oh, I'm sorry. I meant to share my screen. I'm like sitting here and just talking. I'm just talking to myself. All right. Sorry about that. Share screen. All right. Better. So in here, you would say, we've got these marble tests. We're testing map as someone might use it with like, here's an observable and we're piping values through it. And we've got this testing apparatus that's designed for testing operators that uses these marbles to kind of virtualize time and ensure that things happen. And we can vertically align to be like, okay, so these things happened at the same time. And when I got the value 1 and I ran it through this mapping function, I got these results back. So I can go through and I can test that it works with multiple values, that it works with one value, even though it should be obvious from the other. I don't care. Like, I just want to make sure. This is what else do we have? This looks like a duplication of the same thing with this add drama. There's should propagate errors from the map function. So if the map function errors, we have a test to make sure that the error is propagated out of the results. If the source errors right away, we have a test that makes sure that the error comes out right away. And then we also assert when we subscribe and unsubscribe from the source to make sure that we don't leave a subscription hanging or like there's memory things. So this is all like the exhaustive list of tests for map, that we have the indexes coming through properly. And, we've got the index and we wait for it to complete and so on and so forth. Like, we've got more tests than we probably even need. And even if one's a duplicate, I probably won't delete it because it runs very fast. And the important bit is that I know everything's covered. And we've got just like 2 or 3, we got almost 3,000 of these. And like, they're even more comprehensive if I were to get into something like, let's see, concat map or something like that. So you can go in and say, okay, well, there's ones that are just kind of testing the old school route with synchronous values. There's these, and those actually exist because these were written before we had these other testing apparatus. There's ones here where we're saying, okay, so here's a bunch of different observables A, B, C, and D. Given this source observable that emits A, B, C, and D, if we map to our observable lookup and concat map down to these, that this is our expected result. And so we've just got like just tons and tons and tons and tons of these to make sure everything is working as though, like, make sure that when you use something in exactly the same way that a user would, the expectations are met. So what I wouldn't do is I wouldn't go and be like, oh, well, let's pull out just that, like, whatever, that callback that we're giving to our function. Like, I'm not going to be like, oh, I'm just going to take this thing out and unit test it, because that does me no good. Like, maybe it might be slightly helpful to help me work temporarily, but like, in the end of the day, if I ever go through and change map to do something else, then I'm screwed. Like, I'd have to go, like, if I was going through and we had that map subscriber down here before, the, whatever, that class, if I was testing that map subscriber, that's gone now. Like, all those tests are useless. I'd have to delete them. So I'm not using, you make sure that your tests are using your code or exercising your code in the same way that your users would. And that goes for whether or not you've got a user interface or a public API, like through functions or, a REST interface or whatever. Use it like your users would and make sure that you're getting back the responses you would expect.
Awesome. All right. And the last one, Ben Stav asked if you have any thought about the observable constructor being like entirely synchronous or not.
Oh, so the Zalgo. So Zalgo came up early on whenever there was a proposal in the TC39 for like adding observable to JavaScript. And actually, interestingly enough, I've chatted with Isaac Schuleter, who is the author of the article about Zalgo and releasing Zalgo. That's a much like the kind of the source of that meme about if things should always be asynchronous, otherwise you can cause trouble or whatever. And even he agrees that a type like observable, like a reactive programming type, should not be all forced asynchrony. And there's a variety of reasons for that. But first and foremost, if you're doing things in a reactive way, like whether it's synchronous or asynchronous doesn't really matter. But also there's things like if you wanted to be able to model DOM events or something like that with an observable, you can't if you have forced asynchrony. You just simply can't, because DOM events, you can actually register them and call them in the same job. Like they can be totally synchronous. You can register them, call them, and unregister them. Totally the same job. So if you force asynchrony, I'll put it this way: if something can be synchronous or asynchronous, you can always compose the asynchrony into it. But if you force asynchrony, you can never force it to be synchronous again. You're doomed. Like it's stuck being asynchronous no matter what you want to do. So it's one of those things where, like, if promise was both lazy and had the ability to be synchronous, we wouldn't need AbortController or anything like that, because you could just use a promise as like, here's my abort signal, like because cancellation needs to happen synchronously. So we purposefully didn't do that to make observable as flexible as absolutely possible, because it's a primitive.
Awesome. Yeah, I agree. And to be honest, like none of the other primitives are asynchronous. So if you look at like streams or event emitters in Node, like everything that needs the ability to react synchronously has to be synchronous. So I definitely agree with the answer. All right, awesome. So thank you so much, Ben. It was very interesting. I'm really looking forward to the refactor and trying it out. Awesome.
By all means, please try out version 7 of RxJS. These updates and these smaller refactors. We're already pushed out one refactor. It's going to be even smaller in the next one we push out. But just so everyone's aware, the beta is pretty well battle tested already. Google uses it in production, if that helps anyone make up their mind. We do have breaking changes that come out, but like they're corner casey stuff. Like we're really trying to not break anything unless it's something where this is just a weird behavior that doesn't make any sense and no one would ever do this anyways, kind of stuff. And we try to keep everything really well documented. So
awesome.
Please try it.
Yeah, please check out the new RxJS beta. 3,000 integration tests. That's more than I have. All right, awesome. Thank you very much, Ben.